So hello, everyone. Thank you for joining the webinar today. My name is Nick Pusateri, and I am a senior specialist here at GoEngineer, and I reside out of the St. Louis, Missouri office location. So today I will show you how to import your custom SN curve data into a custom material in SOLIDWORKS and more. So a little bit of facts or fun facts about me are in my past career, I was actually an automotive mechanic. I actually was a mechanic for almost 12 years. I worked on everything from gasoline aspirated engines to diesel engines. I got burned out in that world, went back to school for mechanical engineering, got my degree, and I've worked in a number of industries like it says here on the screen. I am certified in pretty much everything SOLIDWORKS Simulation desktop, with respect to SOLIDWORKS Simulation desktop application. There is way more than that that you can get, but if you have any questions about that, let me know. You can always send me an email. That's my email at the bottom right of the screen if you'd like to know more about SOLIDWORKS Simulation certifications. But some fun facts about me also are not only was I a mechanic in the past career, I do like to stay healthy, so I do some weight training. I don't lift as heavy as I did before because the whole getting old thing catches up with you, right? And then I also like to shoot compound bow just for target purposes. I don't do any actual hunting, but I like to shoot compound bow. So our agenda for this presentation is we'll first start at the top with what SOLIDWORKS packages offer, which SOLIDWORKS packages offer fatigue analysis. Then we'll move on to what type of fatigue analysis can be done. Then I will show you how to import your own custom SN curve data to be used in a fatigue study. And lastly, I will run a simple fatigue analysis using that custom SN curve info I've imported in. So what packages of SOLIDWORKS offer fatigue analysis? So the SOLIDWORKS simulation package called SOLIDWORKS Simulation Standard comes with fatigue analysis. Then as we go up in the packages, you have everything else listed below. So basically, if you have SOLIDWORKS Sim Premium, you have everything in SOLIDWORKS Sim Premium plus everything below. So Sim Standard is where you are first able to get a true fatigue analysis tool in SOLIDWORKS Simulation. Next is what type of fatigue analysis can be done with SOLIDWORKS Simulation. So when you go to create a new simulation study, you will see something like this here. So depending on the licenses of simulation you have is what icon lights up to be used here. So with respect to fatigue, you will see there are 4 options to choose from. The first one being constant amplitude, which of course requires a license of Sim Pro or Sim Premium to use. But at a minimum, you need Sim Pro. The second one is variable amplitude, which also requires at a bare minimum license of Sim Pro or higher to be used. The third one being is harmonic fatigue of sinusoidal loading. And with that one, you need a bare minimum of Sim Premium to use it. And the fourth one is random vibration fatigue of random vibration. And at a bare minimum, you need Sim Premium to use that one also. Note here, I want to make sure that you understand the type of fatigue analysis method I'm going to be using today for this webinar is the constant amplitude fatigue. So fatigue analysis in SOLIDWORKS Simulation Professional or SOLIDWORKS Simulation Premium is all high cycle fatigue analysis. Low cycle fatigue analysis does exist, but it is not supported in SOLIDWORKS Simulation desktop application. So here you can see some of the key differences between high and low cycle fatigue analysis. So for example, for high cycle, it is preferred to run more than 10,000 cycles, while low cycle is you can range between 10 and 10,000 cycles. For high cycle fatigue, the stresses must remain below the yield strength of the material for the whole analysis. And then lastly, the high cycle fatigue analysis is based on stress life using an SN curve method. Now, if you are in need of a low cycle fatigue analysis, analysis application, then we recommend a tool or a role on the 3D Experience platform called Durability Mechanics Engineer. So this role enables comprehensive structural simulation covering statics, implicit and explicit dynamics, and low and high cycle fatigue analysis to assess structural integrity of any type of product. So some of the key values delivered for this role include industry-leading abacus solver, strain-based multi-axial fatigue solver, tightly coupled with structural simulations, and with a broad range of fastener, connectors, and weld models. So good stuff here. And then, of course, here's an example of using the Durability Mechanics Engineer role on the platform. So this Hyundai steering knuckle failed in a fatigue test near the bolts when under a typical driving load. But how would it fail in its worst case loads? So like when hitting speed bumps or potholes. So the part fails faster, but still near the bolt holes. So it's I'm kind of working left to right here. So that was the first scenario. Here's the second scenario. However, when in real driving situations, the knuckle breaks in a completely different area. Why is that? Well, in reality, the load cycles are in combination. So using the Durability Mechanics and Engineer role on the platform, you can represent these duty cycles accurately. So this is only one example of how durability in 3D Experience can represent reality accurately. So the next topic to cover is, well, how do I import my custom SN curve data into a fatigue study to be used in SOLIDWORKS Simulation? Well, now the order of operation I'm going to show you in SOLIDWORKS goes like this. And this is basically kind of like the recipe of how you would do it successfully to bring in your SN curve data to be used. So we're going to first create a linear static analysis that will be used in the fatigue study. And then, of course, for purposes of saving time today, I'm not going to go through the whole complete setup of the linear static study. I'll just kind of do a review. So just, again, just for saving time, we'll then make a custom material within the linear static study. Now, that custom material will be used for the fatigue study because that's where we're going to input our SN curve data. We'll run the linear static analysis with our custom material. We will then create a fatigue study, and then we will import in our SN curve data using that custom material that we created in our linear static study. So that's kind of the recipe of how you go about doing this correctly. Now, you may or may not have already know this, but have you ever wondered what the SN or even the SS means at the end of the name of a material in the SOLIDWORKS material library? Have you ever seen that before? Well, the SN means that this material already has an SN curve data built into the material data to be used for a fatigue study. While the SS stands for stress strain, which means that that particular material has a stress strain curve built into the material to be used in a nonlinear analysis using SOLIDWORKS Sim Premium, of course. So here is just an example of using the material named 7076-T6, and it has an in parentheses SN. So as you can see, it has the SN curve data already listed in the material info. So that's not something that was typed in. That came already in with the material within SOLIDWORKS material library. And also, you're not bound by using a single set of SN data. You can enter up to 10 curves for different load R ratios. It does start at curve 0 and it goes to curve 9. It's the same thing as saying 10, a total of 10. It just starts at 0. And then lastly, you can also view a graph version of your SN data that you've imported in. It's just a button you click, and then you can view a graph version of that. Now, you can either use real-world test data results or get an SN curve from a book that has lab-tested SN curve info on, let's say, steel materials. So for this webinar, I went ahead and used SN curve data from a book called Atlas of Fatigue Curves by Howard Boyer. Now, this is a book that you can purchase online, of course. And the SN curve data I decided to use from this book is shown here in the red box, which is the 1.2% carbon steel. So that's the data I'm going to use for my for importing in SN curve data into my fatigue study. Now, before I move on here, I want you to notice something. Notice that the x-axis data is number of cycles for rupture in log scale, while the y-axis is maximum stress and PSI. So remember that. We'll come back around to that, okay? So y-axis says maximum stress PSI. So in order to take this chart data into my SOLIDWORKS fatigue study, I use an online application called Plot Digitizer to import in the chart info from the book, and then from there, it will output a CSV file of your chart data. So this thing is actually really easy to choose. You just kind of say, what's your X min, X max, Y min, Y max, and then you type in the values on the right side, and then right from there, or then you kind of click wherever the values are on the chart, and then it outputs a CSV file that you can use. It's pretty neat stuff and very easy to use. Now, in order to use the CSV chart data info from the Plot Digitizer application, you will need to convert the y-axis data, which was maximum stress PSI, into alternating stress instead of max stress. So here you see the math of how this can be done. So you simply choose an R ratio value. So you kind of go into this knowing whether you're going to use fully reversed or zero based, 0 or -1 value for R. And then you solve for sigma min using the CSV chart max stress value. So you know what you're going to use here already. You know this came from your chart from the Atlas book, and then you just kind of back calculate the sigma min value. And then from there, you're able to, or should I say, once you know sigma min, then you can calculate the alternating stress. So what I did here is, in a simple spreadsheet, I made where I copy and paste in the plot digitizer info or the CSV file stuff, info here in the spreadsheet, and then let the spreadsheet calculate the alternating stress y-axis values I need to import into a SOLIDWORKS Sim fatigue study. So as you see here, I just, like I said earlier, this is kind of the math here. A 0, max, let it calculate min, and then use the equation for finding alternating stress. So this whole column is based on zero-based, and this whole column is based on fully reversed. And I just basically took these values here and put them into these yellow box values here. So basically what I did was let the spreadsheet do the calculations, and I'm going to copy and paste these values in the yellow boxes into my fatigue study for my custom SN curve data. Notice that I'm not using just one SN curve data. I'm using two, one zero-based and one fully reversed. So enough of the PowerPoint slide info. Let's next see how all of this would be done in SOLIDWORKS Simulation using this Trunnion model. So here's my assembly open in SOLIDWORKS. Of course, I'm using 2024 SOLIDWORKS Simulation. And if you're curious what the heck a trunnion is, a trunnion, if you didn't know, it is basically a cylinder protrusion used as a mounting or a pivoting point. So this would be like a pivoting point, and this would be a pivoting point. Okay. So like I said earlier, what's the first thing we're going to do? Well, let's make a linear static study. And let's go with static. And I'll just call it webinar linear static study. How about that? So there's our static study. Now, in this case, if I go to the parts folder under the sim study tree here, you'll notice that there's already material for each of the components. So where did that come from? Well, of course, if it has an SW in front of it, that means it came from the feature manager tree where each individual component was given a material, right? So in this case, I'm not going to use the SW cast carbon steel, SW alloy steel. I'm going to create a custom one, right? So let's right click on the parts folder here and click on apply material to all, because I want to give everything the same material. All right, so what I'd like to do is under the category of SOLIDWORKS materials under steel, what I'd like to do is I'm going to right click on cast carbon steel and choose copy. And then I'll just go ahead and close everything back up here. And then under the custom material folder at the bottom here, if you're following along or going to follow along later, ahead of time, I already went ahead and made a subfolder in here called webinar material. But how did I do that? Well, I basically right clicked here and I made a new category, not a library, but a new category. When you choose new category, it'll put a subfolder on your custom material folder. And of course, you can name it whatever you want here. In this case, I'm going to go ahead and right click here under this folder called webinar material. I'm going to paste in the cast carbon material I copied from above. And then if I open this up, here is that material and all of the information that goes to that. And you'll notice that, of course, everything is kind of in this white box here. Normally, when we see this in SOLIDWORKS Material Library, it's all kind of grayed out, right? Well, now you can actually physically click in here and change the numbers around, right? Because you're making a custom material. Now, another thing to note here is whenever you copy something from above and then paste it into the custom material folder, you should rename it, okay? It's kind of good practice to always rename it. So let's go ahead and right click and rename this, and I'll just do -sn data, and I'll do the date today. I'll just do 4/18/24. All right. So order of operations: create a linear static study, and then you create a custom material, right? So we'll go ahead and hit save. Oh, please select the material. So we chose this, and then I'll hit apply, and then it saved it, and then we'll hit close. And of course, it has applied all of that material to all the components of my assembly. Now, I'm going to go back to my existing linear static study over here, and maybe you know this already, maybe you don't. But why reinvent the wheel if I'm going to do the same setup in my new study from an old study? I can just basically use the existing connections, the existing fixture, and the loads from the previous study by doing this. I'm going to left click on the connection folder, holding down my left mouse button, and drag it over to my new study. And then when you see that blue arrow, let go. And then if I go over here, now I have all my connections. So I didn't have to redo that again, right? I'm going to do the same thing for not only the connections, I'm going to do it for the fixture. In this case, it's a hinge fixtures we're using. And that'll do it for the external load, which is 5,000 pounds. And I will also copy the mesh. And of course, when you do that, it says, please remesh. That's typical. All right, so let's go back to our new study now. And what I'd like to do is let's confirm that we do have all the connections, local interaction bonded connections here. So we'll use that old right click on connections and turn on interaction viewer. Now that this verbiage has changed in 21 and up. Maybe you're using an older version. I think they called it contact visualization plot or something like that back then. But the new version, or the new verbiage, is interactive viewer. And if I hit that and then hit calculate, because the whole assembly is listed in here, you can see where in red, all of the bonded connections have been made. So everything's bonded together here. So we're good there. I'm going to hit Control Q and then also show the fixture, and let's show the actual load here. So I chose the hinge fixture on this cylinder and this cylinder, and I just did 5,000 pounds pulling up on this cylinder face here. And let's go ahead and mesh this. So for meshing, I used blended curvature. I didn't change any of the values here. I just kind of went with the default values. Let SOLIDWORKS choose for you. Go ahead and let it mesh. So everything we're using right now is solid tetrahedral high quality element. So it looks good. We'll go ahead and run with that. And let's go ahead and right click at the top and run this. Well, actually, you know what? I'm going to hit save. I always like to save and then run. Go ahead and save this, and then we'll go ahead and run it. It shouldn't take very long to run. All right. So let's go ahead and finish writing everything to the C drive. And we'll go ahead and close the tree icons up here and view the results here a little bit. And what I'm going to also do is I'm going to hit the little eyeball symbol to hide all the little arrows that were in the view here. All right, so The typical output for linear static analysis is the von Mises stress. So we're at, in terms of PSI, we're at 11,263. We haven't yielded, right? So we're good there. Displacement wise, now this is scaled up 448 times, by the way. So for both von Mises stress and displacement, we're scaled up quite a bit. And we're barely moving here at 0.004 inches. Now, what I'd like to also do is just show you, hey, you can actually make new plots, in this case, new stress plots. So I'm going to make an additional couple of plots here. I'm going to make a principal P1 stress plot. Hit the little pin button here to leave the tool open. So there's the principal stress plot. And I'm also going to make the stress intensity P1 minus P3 plot. Hit the green check. And then X out. And then, of course, you can observe these plots. So von Mises stress, we were at a maximum value of 11,263 for the principal stress, P1 principal. We're at 11,320 PSI. And then for the stress intensity, we're at 11,326 PSI. So not that far off from each other, right? Now, you're probably wondering, well, why am I doing this? Well, you'll see here in just a moment. So let's see. We have our study made. Let's create a fatigue study now. So we have our linear static study. Nothing's yielding. And now let's make a fatigue study. So let's go into up here at the top. Under the Simulation Command Manager tab, we'll go to New, Study, and then down below here it shows Fatigue. And just like I showed you earlier, there are the 4 options to choose from. So depending on the license of simulation that you have is what lights up over here, or what's not grayed out. So like I said earlier also, I'm going to use constant amplitude, which is the far left, and we'll just call this webinar fatigue study. It's always good to give your studies a particular name, right? So if you walk away from this for a while, you can come back and know what study is what if you give it particular names. Fatigue study. All right, so if I now, let's see here. Let's go ahead and let's right click at the very top here. And I'm going to go into the properties of this study real quick here. And oh, I'm sorry. No, we're gonna actually bring in our actual custom material right now. So what I'm going to do is, first off, I need to create an event first. So I'm going to right click here and choose add an event. And how many cycles am I going to do? Well, that's kind of up to you, right? So it's like, that's what you want to, how you want to test it in reality. So I'm going to go with 1e to the 6th, which would be 1,000,000 cycles. I'm going to go with fully reversed. You can choose zero-based loading or find cycle peak here. So I'm going to choose fully reversed. And the study I'm going to reference for this fatigue study is the webinar linear static study down below here. So I'll bring this, drag this out so you can see that's the study I'm using for my fatigue study. I'm using fully reversed loading type, 1,000,000 cycles. And the scale is basically meaning that I'm going to take whatever my load is in my static study, I'm going to take it times 1. So if I'm using 5,000 pound load, I'm just going to take 5,000 times 1 here. If I was to put 2 in here, it would take 5,000 times 2. All right, so I've created my event. Now when I do that, all of a sudden you get a parts folder here, and all of my components are listed here. But what's missing is actual, well, what material am I going to use for this? Well, if I right click on the parts folder here and hit apply fatigue data to all bodies, this opens up, and what's kind of grayed out but still kind of bold black lettering here is the material I made a few minutes ago, which was the cast carbon steel SN data and the date, right? Well, there's some settings that you can change here. There's the interpolation method of log, semi-log, and linear. I guess you could say log is normally used when the defined SN curves have few data points that are widely scattered on both axes. Semi-log is normally used when you have relatively small stress ranges compared to the variation in the number of cycles. And linear is normally used when the defined SN curves when your defined SN curve has many data points. So I'm going to leave it as log for the interpolation method to be used. For the define here, this is where I showed you in the PowerPoint slide that you can choose up to 10 curves to input. So in this case, I'm going to leave it as curve 0 at -1. And if I leave it at -1, notice that the stress ratio down below here is -1. And of course, you can set the units of what is the units of the data you're going to bring in here. I do want to comment real quick on the derived from material elastic here. If I click on that, you are able to choose these little radio button options here. So if your fatigue curve is unknown and either austenitic or carbon steel is used in the analysis, the derived from the material elastic modulus can be used with the appropriate steel here. So the software uses a known ASME SN curves for these two types of steels to be used. So this is if you didn't have a fatigue curve known to use. But in this case, I do. So I'll leave it as define. I'm going to leave it on the setting of curve 0. Make sure that my stress ratio value is set to -1. And we'll go with PSI as my units. So always make sure your units are correct before you drop anything in here. And here is that little spreadsheet that I made. So I'm going to copy the cycles. And I'll just kind of put this over here and push this over here. Is that right there? Okay. So there's my cycles, and we'll go ahead and drop that in here. So that would be a Control V, V as in Victor on my keyboard. So there's my cycles. And then, so since I'm using -1, that's the fully reversed. So I'm going to bring in this data here. So copy this data and drop it into this column here. So again, this is all PSI units. So make sure the units are set correctly before you drop it in. And then we get this little graph here. And of course, if you want to see a bigger version of that, if you click View, you get this graph look of it, alternating stress and cycles. So again, SOLIDWORKS simulation, fatigue analysis, the y-axis has to be in alternating stress. All right. All right, so that's my first curve. So I'll hit save. Now I'm going to bring in my second curve data. So this is easily just a drop down. We'll do curve -1 now. And in this case, we're going to set it to 0 for our ratio. Make sure the units are set to PSI. And again, using the same cycles info as we did before. By the way, if you have any questions, let me kind of pause for a second. Go ahead and send them in the Q&A. There's a little tab that should say Q&A. But if you have any questions while I'm kind of going through this, I'll address these questions at the very end here, but go ahead and post them in the Q&A tab. All right, so where were we? We were dropping in the cycle info. Now we're going to drop in our zero-based info, alternating stress. And there it is. And of course, you could always view the graph. Clicking on view and view the graph here. Again, alternating stress is in the Y and the cycles is in the X-axis. Hit save. Now I'm going to hit apply. So apply means that since I have two curve data inputted here, it says variable over here because I'm using two SN curves for my fatigue study. Go ahead and hit close. All right, so we're good to go there. So what are we going to do next here? Well, next we're going to run the fatigue study, right? So let's see how that's done here. Well, what I'd like to first do is let's start again at the very top of the tree here and just kind of comment on the properties a little bit. So in this case, for constant amplitude event interactions, I'm going to go with random interaction. So that means that the software considers the possibility of mixing stress peaks from different events. The no interaction, what does that mean? The software assumes that the events occur sequentially, one after the other without any interactions. That's what these two mean. And if you remember earlier, when I did the linear statics study, I made two additional stress plots. One was, or the first one was the von Mises, which is the equivalent stress. That was the default output value, right? Or the default output plot, I should say. And then I made a stress intensity plot, P1 minus P3, and then I made a P1 principal P1 plot. So this is where you can choose which one you want to use for computing alternating stress from your linear static study results. So in this case, I'm going to tell it to use the stress intensity plot value. Now these values in the stress in the linear static study were not that far off, so it's okay to use one or the other here. But again, you can choose which plot of information of stress to use for the fatigue study. All right, then there's let's see here. We have what's called the mean stress correction here. So think of it like this. If you were to take your material and have it tested at a lab, they're going to do more of an axial pull on your material till they find where it breaks, right? So they're going to continually pull it axially in cycles until it breaks. Well, that's one style of loading, right? What maybe your style of loading is not that way. Maybe it's, in this case, for this trunnion, it's completely like fully reversed. What if you're pulling up here and pulling down? So in this case, we have two different style of methods of running a fatigue study. One was lab test based versus what you're doing in reality here. So because you have two different kind of methods of doing things, a fatigue study, you can counter in a mean stress correction option or a factor here of either none, Goodman, Gerber, or Soderberg. None basically means whatever you put in that graph for your data, it's going to use exactly what your graphs say. That's what none means. Well, Goodman, Gerber, and Soderberg, which means that it could adjust your curve downward in some way, depending on the method done by Goodman, Gerber, or Soderberg. So they always kind of say Goodman is recommended for brittle materials. Gerber is recommended, Goodman is for brittle materials. Gerber is experimentally shown to be good for ductile materials. And then Soderberg is the most conservative in terms of results. So this is, it's kind of, again, your option to choose from. So in this case, I'm going to use Gerber. And then down below that is the fatigue strength reduction factor. So what does that mean? Well, this is where we take into consideration surface conditions, the size, load, temperature, reliability, and miscellaneous effect factors. So in this case, you have a choice to do either, I don't think you can do 0. Can you do 0? No. You can either put in like 0.1. It's either between 0.1 and 1, somewhere in between that, but you can't put in 0. And I don't think it goes any higher than 1. So what does that mean if I put 0.1? Well, that means I'm going to do 10% reduction factor to be used for this fatigue study. If I put 1 in, I'm saying use 100% fatigue reduction factor on my particular study. So in this case, I'm just going to roll with 10%. So that's the fatigue study properties setup. We've already created our event. The event is the cycle load is going to do. And what type of loading? It's fully reversed, which means we're going to pull up here, go back down to initial position where it started at, and go down in that direction 5,000. So pull up 5,000, go back to initial, and go back down. All right, so that should be it in terms of setup. So I'm going to go ahead and click save, and we're going to run this now. And pretty quick run for this. We're getting some results here. And the typical outputs of fatigue or SOLIDWORKS Simulation desktop application fatigue analysis is a damage and a life plot. So for the damage plot, it's basically on the right side here. What I like to do is I'll adjust this to say 0% damage, meaning there's no damage. And then I'll change the top value to 100% damage, which means there is permanent damage done in this area in red. So therefore, anything in blue is no damage, and anything in red is permanent damage based on that fatigue study that I've run. So that's a damage plot. And then there is the life plot. Well, life plot is just telling you the life expectancy of cycles that it can actually do in reality based on the fatigue setup you've done here. So you don't really look at the highest necessarily that it can do. You look at the lowest, because that's where it's going to fail in the lowest cycle. So I'm going to left click here, choose annotation, hit the green check mark, and of course where the blue is where it will have the least amount of cycles till it hits failure. So we're hitting it at 37,420 is when these areas will fail in terms of cycles. All right, well, going back here. Well, that was really it. I was going to show you for the webinar today for fatigue analysis, bringing in your own custom SN curve data. If you would like to learn more about SOLIDWORKS simulation or the simulation training that we offer here at GoEngineer, simply go to goengineer.com and then put your mouse cursor on training and go to our course catalog here. And it will list all of the training that we offer. So we have training, from self-paced training. We offer online training, live instructor online. We offer office training, of course, live office training, on-site training. And then I think that was pretty much, yeah, that's what we offer in training. But you can get a whole listing of the catalog of everything we offer for training, for CAD training, SOLIDWORKS CAD, SOLIDWORKS Simulation, whatever, PDM. Also, if you are already a customer of ours here at GoEngineer and you're on subscription with us on any product, so it doesn't have to be simulation. It could be PDM, CAD, whatever. Then your entire company gets 4 hours total free per year to schedule what is called an application mentoring session. So if you go to GoEngineer.com and you go under support here, there's a little application mentoring session here. So again, if you're a customer of GoEngineer and you're on subscription with us, you get per year 4 free hours, and it's 1-hour sessions normally of what's called an application mentoring session to get help from one of our expert simulation, CAD, or anything else. You may even be talking to me, you know. So if you're needing help on a simulation setup, or just why am I getting this issue with SOLIDWORKS, no, that would be normally a support case thing. But if you have any questions or curious of how to do certain things in SOLIDWORKS simulation, you can make an application mentoring session. So thank you everyone for attending this webinar today. Feel free to email me at as you can see on the screen here, in Pusateri at GoEngineer.com if you have any questions after we end this presentation today. So that concludes today's webinar. Thank you for attending. And if you guys have any questions, go ahead and post those in the Q&A here. Mike, they will have this, if you're still out there, Mike, they will have this posted on YouTube, on GoEngineer's YouTube page. Does that help? Let me know. Yeah, hopefully you guys got a lot out of this. Sounds like you guys did. The reason we did this particular webinar is because the training book is a little dry on telling the student how to actually bring in SN curve data in the SimPro training. It doesn't even actually tell you how to do it. It just kind of says, hey, there's already one already done for you. And that's why we decided to go with this, is because we felt, or we found there was a need for that out there with customers. Any questions? Anybody else? If so, put it in the Q&A tab there, little tab that says Q&A, post your question there. Give it a few more minutes if anybody's typing in a question. Warren, Chris, hopefully you guys got a lot out of this. Let me know what you think of the webinar. Maybe send a little comment there. Mm-hmm. Again, if you're still here, if you have any questions, let me know. Send it in the Q&A, or you can always email me at npusateri@goengineer.com, which is on the screen here. Let me see if I can answer Mike back if he's still out there. Yeah, if you're curious, everybody, usually we post these webinars on our GoEngineer YouTube channel within a week or two. It should be posted out there. Well, for those who are still here, if you are, I'll go ahead and close everything out here. But again, if you have any questions, feel free to email me at npusateri@goengineer.com, which is of course on the screen. But other than that, thank you for attending the webinar. I'll go ahead and end everything out here. Have a good one.